Okay, so this video is going to be part 1 of 10.2, or just what we went through on Friday, up to where we got to on Friday. So 10.2, we're adding another method for solving quadratic equations to our toolbox. The thing is that this method is not the most efficient method. It is foolproof, meaning that it will allow you, if there are real solutions to a quadratic equation, it will allow you to find those solutions or solve for those solutions. But you'll see that the final method of solving quadratic equations, so using the quadratic formula, will actually be your kind of more go-to method for solving quadratics that can't be solved by factoring or square root method. But in order to derive the quadratic formula, you need to be able to complete the square. So we're going to start this lesson off by completing the square for quadratic expressions. And this is going to be useful to you guys. Completing the square of quadratic expressions, or knowing how to do that, will be useful for you in, say, Algebra 2, whenever you are graphing quadratic functions using translations or transformations, or from what we call vertex form of a quadratic equation. And then also in pre-calculus, when you guys are studying conic sections, being able to complete the square on one side of the equation, or of a of an expression, is useful. Okay, so like I was saying before, is you can't always solve a quadratic equation by factoring or square root method. So such as the equation down here, there's no way to solve this, there's no way to factor this equation, and there's no way to solve using square root method, because we have that middle term of minus 10x. So we're going to be using this more general procedure to solve equations that can't be solved using the other methods, which is known as completing the square. And I hope you'll see why it's referred to as completing the square. But like I said, we are not solving quadratic equations yet by completing the square. We're going to start by completing the square of quadratic expressions. So there's no solving. We are going to be rewriting a quadratic expression in a different form. Just like when we started by factoring quadratic expressions, we were rewriting the expression as a product. But now we're just going to be rewriting these quadratic expressions in what you could refer to even as complete the square form. Okay, so the idea behind completing the square is to transform any standard quadratic expression in the form ax squared plus bx plus c into this other form, where you can see that there is a square. Now, don't get too hung up on what what capital A and capital B are. I'm going to start by showing you guys how to complete the square of just the general quadratic expression. So ax squared plus bx plus c. So I'm going to rewrite that over here. And I may run out of room, but we'll see. So I'm going to start by factoring a out of the quadratic expression. So I'll then have x squared plus b over ax plus c over a. And you can think if you were to distribute the a back in, you would just have the original quadratic expression. Okay, so now I'm going to rewrite what I have, but between b over a times x and the constant c over a. Remember, a, b, and c are just constants. So c over a, b over a, those are just constants. But I'm going to leave a space. Okay. And remember that if you, this is a property of real numbers, but if you add the opposite of a real number to itself, you get 0. For example, 2 plus negative 2 is 0, which is the same as 2 minus 2. So we're going to do that. I'm going to add 0 to this expression, because then, remember, when you add 0 to a real number, it's just itself. So I'm going to actually add b over 2a squared, and then also subtract b over 2a squared. And I can do that because this is really just 0. I've basically just added 0 to the expression, so the expression is still equal to itself. Now, I'm going to rewrite this, but by the associative property of addition, I'm actually going to group the first 3 terms that are in the brackets here. So x squared plus b over ax, and then this is, when simplified, b squared over 4a squared. Okay, so then we'll have minus b squared over 4a squared plus c over a. Okay, I can do that by the associative property of addition. I just reassociated those numbers, or those values, those terms. I reassociated those terms. Okay, now, this might look like magic, but I can prove it to you. This is going to always factor. This is actually a perfect square trinomial, and it will always factor to x plus b over 2a squared. Then we still have the minus b squared over 4a squared plus c over a. And the last step is to distribute that a back in, so we would have a times x plus b over 2a squared minus b squared over, that'll end up being 4a, the a will cancel with an a in the denominator, plus c. Now it's important to remember a, b, and c are just real numbers. Okay, so b over 2a is just a number, it's a constant. And then minus b squared over 4a plus c, that's also going to be a constant. Okay, so that's where we get above here whenever, so whenever we have plus capital A plus b, that capital A down here would be the b over 2 lowercase a, and then the capital B would be the minus b squared over 4a plus c. And then I also said that I would prove to you, I'm going to add a page, I would prove to you that this will always factor to this. And I'm going to prove it to you by multiplying that back out. So by taking, by taking x plus b over 2a squared, which is x plus b over 2a times x plus b over 2a. When I multiply that out, I should end up with x squared plus b over ax plus b squared over 4a squared. Okay, so when I distribute the x's, I get x, or the x, I get x squared. Okay, then we'll have plus b over 2ax plus b over 2ax plus, that's going to be b squared over 4 a squared. Now, these are like terms. B over 2a x times x plus b over 2a times x. Well, 2a and 2a, we have common denominators there. That's actually going to be x squared plus 2b over 2a times x plus b squared over 4a squared. And those 2's can cancel, so we get x squared plus b over a times x plus b squared over 4a squared, which is what we had up here. Okay? So I think it's less confusing once you do this with actual numbers. Let's pick a color. Let's use the dark red. Okay, so what I'm going to do is I'm going to rewrite this where I leave a space between the second term and the constant. Okay, so here's where I'm going to add 0 to the expression. I'm going to use a different color to show this. So I'm going to add, remember, b, which is 8, over 2 times a. Remember, a is just 1 in this case, so it's just actually b over 2, so squared, and also subtract that value. So when I simplify that, we'll have x squared plus 8x. That'll be plus 16 minus 16. Now, by the associative property of addition, I'm going to group these three terms together. And this will always factor to be x plus half of b, which in this case will be 4 squared minus 19. And if you don't believe me, you can think about factoring that using guess and check. Right? You draw your little picture. 4, 4, oh, guess what? That would work. X plus 4 times x plus 4. So this is what we mean by complete the square. Notice that we added and subtracted a number in order to create a perfect square trinomial, which will factor to be a perfect square. So x plus 4 is squared. Okay, let's do another one. Let's switch colors too. We'll go to purple. Okay, so starting the same way, x squared minus 2x, leaving a space. So I'm going to add, the leading coefficient a is 1. So I'm just going to actually take b, which is negative 2, and divide it by 2. So it's negative 1, and then square it, which will be 1. So I'm going to add 1 and subtract 1. Then I group or reassociate the associative property of addition. That will factor to be x. Okay, b divided by 2 is a negative 1, so x minus 1 squared plus 2. Done. We just rewrote this original quadratic expression in a different form. If we were to multiply x minus 1 times x minus 1 back out and add 2, we would end up with our original quadratic expression. Okay, so x squared plus 10x, leaving space. Again, a is 1. I'm going to stop before a becomes another value, and we'll talk about that in class on Tuesday. But so I'm going to divide b, which is 10, by 2, so it's 5. So 10 divided by 2 squared is going to be plus 25 minus 25. We group these three terms together. That's going to factor to be x. Half of b is 5, so x plus 5 squared minus 46. And I'll do this one too just for another practice. Okay, minus 2x, leave space. All right, b, I'll write this out actually. So b divided by 2 squared minus b divided by 2 squared actually ends up being x squared minus 2x plus 1 minus 1. Then we can put parentheses around those first three terms. So group those first three terms, which will factor to x minus 1 squared. And negative 1 plus 17 is plus 16. Okay, so we're going to leave off there, and that's where we will pick up on Tuesday. The homework is only on section 10.1, and we will talk about, we'll do some warm-up, sort of warm-up for section 10.2 in class.